Hi everyone, welcome to this GCSE Higher Revision video. The 73 days are going to your GCSE Maths exam, and today we're going to be focused on the topic of conditional probability. So conditional probability, I really like this topic, I just really enjoy it, but it's the idea that the probabilities change after the first thing has happened. So for instance, if you've got the revision cards, this is card number 71 on the higher set, and we've got the inside a bag, there's 2 apples and 3 bananas. Olivia's picking 2 items out at random, and the question is, what's the probability of her finding 2 apples or picking 2 apples? And obviously, if there's going to be 2 apples and 3 bananas, there's 5 items altogether to begin with, and 2 of them are apples. Now, if she takes out an apple, then probably the next one will be an apple. It's not going to be 2/5, it's going to be 1/4, because there's now only 4 items left in the bag, and one of them's an apple. So the idea that those probabilities change, and then whenever you multiply, then you would get the probability of picking 2 apples. So in this video, we're going to look at how to answer some questions on conditional probability. We're going to go through some questions, for you to try as well. And on this topic, because obviously the context can change quite a great deal, what I'd highly recommend is that you look at the practice questions as well. It's quite an important topic, and it can be quite tricky sometimes. So the more practice you do on conditional probability, the better. So let's get started.
Okay, so today we're going to be looking at conditional probability, and this is sometimes called dependent events. Now, we've looked previously at independent events, and that's where whenever one event happens, it doesn't impact the probability of the next event happening. Now, conditional probability is where whenever the first event takes place, it impacts or it changes the probabilities of what happens in the next event. So here we've got inside a bag, there's 2 apples and 3 bananas. So here's a bag, and there's 2 apples and 3 bananas. We're just going to write an A for the 2 apples, and a B, and a B for the 3 bananas. And Olivia picks 2 items at random out of the bag. So she's going to pick 2 items at random. So she's going to pick out an item and then another item. And the question says without replacement. So she's going to pick out a piece of fruit, and then she's going to take out another one without putting the first one back in. And the question says, what's the probability of her picking 2 apples? So if we think back to tree diagrams, now if I was to do this question, I wouldn't draw a tree diagram, but I'm just going to show you to begin with. If I was to do this question by using a tree diagram, well, the first piece of fruit, it could either be an apple or a banana, and then the next piece of fruit could be an apple or banana, or it could be an apple and a banana. So there's the 4 possible outcomes. You could get an apple and an apple and a banana and an apple, or a banana and a banana. Now, in terms of the probabilities, let's label the branches here with the probabilities. So the first piece of fruit being an apple, well, there's 5 pieces of fruit to begin with, and if she was to take out an apple, was 2 apples, so the probability of picking an apple to begin with would be 2/5. And a banana would be, well, there's 3 bananas in there, and there's 5 pieces of fruit, so the probability of being a banana would be 3/5. Okay, so that's the first piece of fruit being taken out of the bag. Okay, so now let's consider if the first piece of fruit taken out was an apple. So let's say an apple's been taken out, so that apple's gone, and we're now left with 4 pieces of fruit in the bag. There's 1 apple and there's 3 bananas. So in terms of the next piece of fruit being an apple, well, there's 4 pieces of fruit because of the first apple's gone. So we've got 4 pieces of fruit and we've got 1 apple, so the probability of picking an apple would be 1 out of 4, or a quarter. And the probability of picking a banana would be 3/4, because there's 3 bananas out of the 4 pieces of fruit, so that'd be 3/4. Okay, so we've labelled the branches there, and that was if an apple was taken out to begin with. But what if the first piece of fruit taken out wasn't an apple? So let's put that apple back in. So we're going to put that one back in. And what if instead of picking out an apple, we picked a banana? So instead of it being an apple, we picked a banana. So if a banana came out, we'd be left with 4 pieces of fruit. 2 of them are apples and 2 are bananas. So if a banana was taken out, the probability of the next one being an apple would be 2/4, or a half, 2/4, 2 out of 4. And the probability of picking a banana would be 2/4, or a half, because there's 2 bananas left. So we've labelled the branches on the tree diagram. Now we were asked what's the probability of her picking 2 apples. So that would be an apple and an apple. So we'd multiply those probabilities together. So we would do 2/5 multiplied by a quarter. And if we do 2/5 multiplied by a quarter, that would be 2 times 1 is equal to 2. And 5 times 4 is equal to 20. So the probability of an apple and an apple would be 2/20. And remember, that could be cancelled down to 1/10. So that's it. So the probability of Olivia taking out 2 apples would be 1/10. And it's just important to remember that whenever we're considering the probability of an apple and an apple, the probability of the first one being an apple would be 2/5. But then whenever she takes that apple out, the probability of the next one being an apple would be 1/4. And then we multiply those together. Okay? Okay, so we've looked at the probability of her getting 2 apples. Now I've changed the question to find what's the probability of Olivia picking 2 bananas. Now normally if I was doing a conditional probability question like this, I typically wouldn't draw a tree diagram. So I'm going to do this question without a tree diagram. So if the question is what's the probability of her picking 2 bananas, so in the bag again, remember there were 2 apples and 3 bananas. And the question says what's the probability now of her picking 2 bananas? That's the probability of a banana and a banana. So if I was to do this question without a tree diagram, well, I'd say, what's the probability of the first piece of fruit being a banana? Well, that'd be 3 out of 5, 3/5. And then because it's a banana and a banana, we would then multiply by. And now we've taken out a banana. So one of those bananas has come out of the bag. It's been taken out by Olivia. So that means that we've got 4 pieces of fruit left. And then the probability of the next one being a banana will be 2 out of 4, or 2/4. So 2/4. And now what we're going to do is we want to find the probability of a banana and a banana. Well, the probability of the first one being a banana is 3/5. The probability of the second one being a banana is 2/4. We now just times them together. 3 times 2 is equal to 6, and 5 times 4 is equal to 20. So that'll be 6/20, and that could cancel down to 3/10, and that's it. So if the question says, what's the probability of Olivia picking 2 bananas from the bag without replacement, the answer would be 3/10, and that's it. Okay, so let's have a look at another question. So this time we're told there's 3 flavours of crisps in a cafe. So there's a cafe that sells crisps, and they've got 3 flavours that are available. There's 4 packets of salt and vinegar, there's 5 packets of cheese and onion, and there's 1 packet of roast chicken. And Bella's going to take 2 packets of crisps at random. So she's picking 2 flavours, or 2 packets of crisps at random from these packets of crisps. And the question says, find the probability that the packets are the same flavour. So I want you to pause this video now and see if you can find what's the probability if Bella takes 2 packets of crisps at random without replacement from these packets, what's the probability that the 2 packets will be the same flavour. So have a go at that now. Okay, so if I was to do this question, well, altogether, let's see how many packets of crisps there are altogether. There's 4 plus 5 plus 1. There's 10 packets of crisps altogether. So there's 10 packets altogether. So there's 10 packets. And 4 of them are salt and vinegar, 5 are cheese and onion, and there's 1 roast chicken. Now we want to find the probability that the packets are the same flavour. So that means that she could have a salt and vinegar and a salt and vinegar, a cheese and onion and a cheese and onion, but she couldn't have a roast chicken and a roast chicken because there's only 1 packet of roast chicken, so she can't pick 2 roast chicken packets of crisps. So we want to find the probability of salt and vinegar and salt and vinegar, and I've called salt and vinegar S there for salt and vinegar, and we want to also find the probability of cheese and onion, and I've called that C for cheese and onion and cheese and onion. And in roast chicken I would have called that R, but we can't find the probability of R and R because there's only 1 packet of roast chicken. Okay, so let's find the probability of salt and vinegar to begin with. So let's start off with salt and vinegar and salt and vinegar. So the first packet of crisps being salt and vinegar, well, there's 10 packets altogether, there's 4 that are salt and vinegar, so the probability of that first packet of crisps being salt and vinegar will be 4 out of 10, or 4/10. And then we're going to multiply that by the probability of the second one being salt and vinegar. Well, now if 1 packet of salt and vinegar has been taken, if Bella takes 1 packet of salt and vinegar, there'd now only be 3 packets of salt and vinegar left, and there would be 3 packets of salt and vinegar, 5 packets of cheese and onion, and 1 packet of roast chicken. And we want to find the probability of the second one being salt and vinegar. Well, that would be 3 out of 9, so that'd be 3/9. So whenever she takes the first packet of salt and vinegar off the shelf, there'd only be 3 packets of salt and vinegar left, and there'd be 9 packets of crisps. And then to find the probability of salt and vinegar, we would multiply the probabilities together. So 4 times 3 is equal to 12, and 10 times 9 is equal to 90. So that'll be 12/90. Now I'm not going to cancel this down just yet because we may need to add it. We're going to add this to the probability of cheese and onion, and if they've both got a denominator of 90, that'll be quite handy. Okay, so let's have a look then at the next one, and I'm just going to rub that out again because now we're looking for the probability of cheese and onion. So on the shelf there's 10 packets of crisps, and we want to find the probability of the first one being cheese and onion, so that's going to be 5 out of 10, so that's 5/10. So that's the probability of the first packet of crisps being cheese and onion. Now if she takes one of those cheese and onions off the shelf, there's now 4 packets of salt and vinegar, 4 packets of cheese and onion, and 1 packet of roast chicken. So in terms of the second packet of crisps being cheese and onion, that'll be multiplied by 4 out of 9 because it's 4 out of the 9 packets. So now we just multiply the probabilities together. 5 times 4 is equal to 20, and 10 times 9 is equal to 90. So we're looking for the probability that the 2 packets are the same flavour. So that's salt and vinegar, or cheese and onion. So we want to add those 2 probabilities together. So if we add those 2 probabilities together, we would get that's equal to 32/90. And then we can cancel that down. If we cancel that down, that would be equal to 16/45. So the answer is 16/45. And if you got that, well done. Okay, now let's have a look at our next part. Okay, so we've got the same information again. So there's still 4 packets of salt and vinegar, 5 packets of cheese and onion, and 1 packet of roast chicken. And Bella's still taking 2 packets at random from the shelf in the cafe, and without replacement. And the question says, find the probability that the packets are now different flavours. So instead of being the same flavour, we're now being asked to find the probability that they're different flavours. So I want you to think about it, that if the probability that they're the same flavour is 16/45, what would the probability of them being different flavours be? See if you can work that out now. Okay, so because either the packets can be either the same flavour or different flavours, that means the 2 probabilities will have to add together to be 1. So that means if we just take the probability of them being the same flavour, the 16/45 away from 1, so if we do 1 take away 16/45, The answer will be the probability that they're different flavours. So 1 take away 16/45 is equal to 29/45. So that means the probability that they're different flavours is equal to 29/45. And that's it. So if I was given this question, which said that Bella was taking 2 packets of crisps at random from this shelf, and we were asked to find the probability that the packets are different flavours, rather than doing like salt and vinegar and then cheese and onion, salt and vinegar and roast chicken, cheese and onion and salt and vinegar, cheese and onion and roast chicken and salt and vinegar, roast chicken and cheese and onion, and so on, what I would do is I probably would just find the probability that the packets of crisps are the same flavour, like we just done, which was 16/45. So that was the salt and vinegar and cheese and onion. We couldn't do roast chicken because that would be 0. And I would just then find that and take that away from 1, and then that would tell me the probability that the flavours would be different, and that's it. Okay, let's have a look at one last question. So this question says Ethan's got 10 coins, he's got 3 10p coins and 7 20p coins. Ethan's going to choose 3 coins at random, and the question says find the probability that he takes exactly 50p. So in other words, he's got these coins, he's going to pick 3 coins at random without replacement, and the question is what's the probability that he gets exactly 50p? So pause the video and have a go at this question out yourself. Okay, so in terms of these coins, in terms of Ethan getting 50p exactly with 3 coins, he could either get a 20p, a 20p and a 10p. He could get a 20p, a 10p and a 20p, or finally he could do a 10p, a 20p and a 20p. They're the 3 possible outcomes which would give him exactly 50p, because if any other option it wouldn't be exactly 50p, because it has to be 2 20p's and a 10p, and they're the possible outcomes that he could get. He could get a 20p, a 20p and a 10p, a 20p, a 10p and a 20p, or a 10p, a 20p and a 20p. So let's find the probabilities of those. Okay, so let's start off with the probability for 20p, a 20p and a 10p. Well, he's got 10 coins altogether, and 3 of them are 10p's and 7 are 20p's, and we want to find the probability for 20p, a 20p and then a 10p. So the first one being a 20p, well, it's going to be 7 out of 10, so that's 7 tenths, multiplied by the next one being a 20p. Well, he's taken out one of the 20p coins, so he's now only got 6 20p coins, and that means he's got 9 altogether, so it's going to be 6 ninths, because there's 6 20p's and there's 9 coins altogether. And then multiplied by the last one being a 10p. Well, he's still got 3 10p coins there, but he's now only got 8 coins because he's taken away 2 of the 20p coins, so it's going to be 3 ifs. So if we multiply these together, we can find the probability of a 20p, a 20p and a 10p, and when we do that we get, and this is a calculator question, so whenever you multiply these fractions together in your calculator, you get the answer of 7/40. So the probability of picking a 20p, a 20p and then a 10p would be 7/40. Now let's find the probability of a 20p, a 10p and a 20p. Okay, so the first one being a 20p, well, he's got 10 coins, 7 of them are 20p, so it's going to be 7 tenths multiplied by, well, he's now taken out one of those 20p coins, so he's now got 6 20p coins left and 3 10p coins, and we now want to find the probability for 10p, so it's going to be 3 out of 9 this time, multiplied by, and then we want to find the probability of the last one being a 20p. Well, he's got 6 20p's left and he's got 2 10p's left, so it's going to be 6 ifs. Now if we have a look here at the numerators and the denominators, we've got the same numbers but just in a slightly different order in this question, so when we multiply those together we're going to get that's equal to 7/40 again. And then finally we want to find the probability for 10p, a 20p and a 20p. You can probably guess what the answer is going to be here, but let's work it out and see. So the probability of the first coin being a 10p, well, there's 10 coins, 3 of them are 10p, so it's going to be 3 tenths multiplied by, well, the next one being a 20p. Well, we've taken out a 10p, so there's only 2 10p's left, so there's 9 coins. The probability of the second one being a 20p will be 7 ninths, so 7 ninths, and now one of those is gone, so there's only 6 20p's left, and then the probability of the last one being a 20p will be 6 ifs. And if we have a look at the numerators and denominators again, when we multiply them together, that's going to be 7/40 again. So we've got the probability of a 20p, a 20p and a 10p being 7/40, the probability of a 20p, a 10p and a 20p being 7/40, and the probability of a 10p, 20p and a 20p being 7/40. Now we wanted to find the probability he takes exactly 50p, so it's either this option or this option or this option, so we add those probabilities together. So we're going to do 7/40 plus 7/40 plus 7/40, so that'll be 21/40, and that's it.
And that's it. So in this video, we've gone through conditional probability. It's quite an important topic, and it happens usually towards the end of the test paper. So it's one that, if you are confident on this, you can pick up some marks towards the end of the paper, which would be fantastic. And in the description below, there's a link to the practice questions, and I highly recommend you have a look at those, because with this topic, the words, the situations can change quite a bit. So the more practice you do on conditional probability, the better. So I really hope you found this video useful. Keep up the hard work. Tomorrow at 3 o'clock, there'll be 72 days to go into your GCSE Maths exam. Remember, please share this with any friends and teachers and so on, just to sort of share the videos because it'll be useful for them, and also it gets the videos more views as well. And can I just say, if you've been watching all the videos so far, well done, you're doing a great job, and keep up the hard work. Okay, cheers, bye.